You're given a slow app and your job is to optimize it. Where do you start? How do you measure what improved? And how do you know if your changes are actually making a difference? In this video, I'm going to give you a framework to walk through when you have a slow app and you want to optimize it. I'll tell you about bundle optimizations, image asset optimizations, code improvements, the new React tools that are available, and server-side rendering. And we're going to take an app that is extremely slow and make it fast. Hello friends, welcome back. I'm Shruti Kapoor, and on this channel I make it easy for you to thrive in React, AI and modern frontend using simple explanations and no fluff. So if you're ready to optimize your app, let's go ahead and get started. This is a clone of Netflix, and in terms of functionality, this is a pretty simple app. We've got a trending now component at the bottom, which has a scrollable list of movies that are trending right now. If you click on a movie, you'll see a little detail of the movie, and then if you play the trailer, it's actually a video of me chopping vegetables because I don't have the real movie. Functionality wise, this is pretty simple, and there's a reason for that. When you're thinking about performance optimization, it is essential that you attack components one at a time instead of taking the entire app and trying to optimize it. By taking a small component, you ensure that you optimize that and then build forward, thereby building an optimized app as you go along. It also makes it easier to track your changes and figure out which change was the most impactful. So this is going to be the scope of our app. Now, while browsing this app, you probably noticed that it was super fast, like there wasn't any actual delay. But remember, I'm on a super fast internet and I have a very powerful Mac. So if you look at the web vital score right now, which is in the performance tab up here, you'll notice that LCP is pretty good, which is 0.4 seconds, which is actually really good. Green also means that your LCP is pretty good. However, it is important that we simulate this for a real user and not the super user that I am. So I'm going to move on to network and simulate this by making sure that cache is disabled and checking and throttling for slow 4G. I recommend testing for at least slow 4G, if not 3G. All right, let's give this a shot and see what our performance looks like. So now all I got to do is reload this and wait for a bit for it to trace. It's done. Look how slow it is to actually load the image. You'll see how slowly it loads. This reminds me of back in the day in 2000s when you would have a really heavy site and it would take so much time to download it. Okay, so now if you look at the LCP, it is in red and it's 28 seconds. That is poor. So this is where we're starting at. Let's see how much we can do in the next 20 minutes or so. All right, step one. Figuring out where to start. Now, the first thing that usually comes to mind when we think of a large website is that it probably has a ton of code, it has a ton of modules, meaning the bundle size is huge. So let's take a look to understand what the bundle size looks like right now of this app. Because if we're shipping a ton of JavaScript to the client, there's not a ton that we can do. The first step we want to do is figure out what the bundle size looks like. To do this, actually first take a look at what our code base looks like. So we've got the source folder here, which is where we've got some assets, and this is where that giant hero background comes that takes so long to load. We've also got some components here. This is pretty simple because we don't have a lot of components. We've got the header component, the hero component, movie card, which is what the little cards look like in the trending now component, the movie detail, which is like the little page that opens up when you want to play a movie list, which is actually a complete list of movie cards where we're just looping through movie cards. And then finally movie player, which is how we're actually loading the movie. Again, if you want to check out the code, it is all going to be linked in the GitHub. Check it out, play with it, break it, do whatever you want to it. And then finally, we've got the theme toggle at the top, which uses a theme store, which actually comes from Zushtan. If you want to understand how this app is built, I'm going to link the full video as well, so check that out. But overall, you can understand that the code is pretty simple. We've got some movies JSON file here as well. It's not necessary, so need to shed this. And then we've got some hooks which help us actually fetch the content. So we've got use movie details, some custom hooks, and use popular movies as well, right? Overall, pretty simple app, nothing major happening. The only thing that I would talk about this is that it uses TAN-stack router. So we are creating an instance of create router in main file. And then we wrap our app with router provider. Pretty simple file. Just by looking at the file, it's kind of hard to understand which of these components are heavy, right? So let's find out a better way to understand which component we should target first to optimize their code, right? The first step we can do is, so in order to do that, we're going to open our Vite config. And here, in order to understand what this bundle looks like, we're going to add a node module called Vite Bundle Analyzer, and I'll add this in the plugins as well. Now that we have this running, let's go ahead and see what our current bundle looks like. To do that, we just have to do Vite build, and that will run the analyzer, give you an idea of what the bundle looks like right now, and will also give you a nice graph to help you understand which of these node modules or components are the biggest. However, before moving on, I also want to take a look at what the actual bundle size looks like. So right now, we've got almost 1.3 MB of bundle. Remember, this may not look like a huge number right now, but this component and the scope is super small. So in short, this is what we're looking at. We've got 28 seconds of LCP, and we're starting off with a bundle size of 1.71 MB. So let's go ahead and start making some improvements. Now, even before we start attacking any components, there's few things in our builds that we can set up. And those are really low-hanging fruit, so let's go ahead and do those first. First up, in your build, set minify to be true. Same with CSS minify, and this just minifies your code so your package is small. And you can also turn code splitting on so that your code is divided into components based on how they're loaded. Why this is important from a router level is because when we know that certain routes are not loaded a lot, we can lazy load them and prevent them from being part of the first LCP. And just with that, let's give it another go and see what our bundle looks like right now. So far, all we've done is turn code splitting on and minification on. Now, if you take a look at your bundle, you'll notice that the little sliver is gone because it has been code split in here. So your CSS files have been split. So you can see which CSS files are taking longer, but the actual source files are also split. Is right here. Now, if you look at this, easily you can tell that movie detail component is the one that's taking the largest chunk. But there's three components that we can take a look at: movie detail, movie card, and movie list. These are the three main culprits that we have. So we have a plan of action and we know which components to attack first. However, remember, we've got tons of node modules here. And it's possible that I added some node modules without even using them. So there's a very easy way of dropping extra node modules. And that is by running npx depcheck. All right, so this actually gives us a list of dependencies that we are not using. So let's go ahead and delete this from our package.json file. Cool. With that, let's go ahead and run the build command again to see if it actually made any impact. Just before removing some node modules, we had 936 KB. And now, okay, I'm going to delete my node modules to make sure that I have a clean install. So we were at 1.71 MB when we started this process, and now we are at 936 KB. So far, we have not made any code change. We're just making Vite optimizations. But now that we know that movie detail component is a large chunk of our package, let's go ahead and optimize that code. We made a bunch of improvements so far, but did it actually help, or was it just random stuff that we did? It is very important that when you're optimizing performance, you measure changes every step of the way to actually see if the changes that you're making are actually helping or just adding bloat. So let's see if the LCP has improved. Head on over to performance and give this a reload, and let's check what our LCP looks like now. Okay, LCP has come down to 21. We were at 28 and now we're at 21. So the changes that we made actually helped. That's good to know. All right, now is the fun part. Let's actually make changes to our React code so that it is more performant. Now, before we even take a look at the code itself, there's a bunch of tools available to us that I want you to first take a look at. You should have React DevTools installed, and if you have the latest version of React DevTools installed, you will see something called Profiler. So Profiler is really helpful in understanding when components re-render and why they are re-rendering. Let's go ahead and record this. So what you want to do at this point is, while the Profiler is running, you want to do the most common flow that a user would be going through. And for every flow, you want to record it separately. So let's do a flow where we actually open a movie, wait for it to load, and then play the trailer. And we'll assume that the user will do this multiple times, which is try a different bunch of movies. I'm going to stop this, and just this flow, I'm going to test what it looks like. So at the bottom here, you'll see that we've got the movie list component, which re-renders multiple times. And at the top here, you'll see how many times components have re-rendered. Each one of this graph is the number of re-renders. Now, some of these are actually bigger than others, right? If you look at this one, this took 2.6 milliseconds to render, whereas the others are kind of small, 0.3 milliseconds. That's something that we can just ignore. So what you can do here is you can hide commits that are below 5 milliseconds. So this will give an idea of which components are taking the longest to render, like this movie detail, which is taking 18.9 milliseconds, and which components are rendering the most. Like in here, you'll see the cards are being rendered so many times. It also shows you why this component re-rendered. So it says it rendered at this, this, and this. So this is a much better view of your React components to help you understand which components are re-rendering. The components that are re-rendering are probably the ones that are causing the most slowdown. So you want to attack those components first. Now, movie detail is a component that is taking long. Movie list renders multiple times. So when we look at this, we understand that movie detail took 15.6 milliseconds to render. This is taking too long. Movie list has a bunch of different like child components that are rendering. This is where lazy import comes in. And then we've got this movie list, which is rendering again. So now this gives us a clear idea of which components to attack next and what to look for. Now, one great thing that we have available today is React Compiler. You'll notice that some of these components here say memo, so they don't actually re-render. React Compiler will memoize your components for you, so you don't have to worry about manual memoization and manual performance optimization. It's now as simple as adding a new plugin, and you get memoization out of the box. Let's go ahead and set up our React compiler. So luckily, installing React compiler is super easy. You just gotta install the Babel plugin and then set it up in your Vite as a Babel plugin. And once that's done, we've gotta make sure that React compiler is added as a plugin. And that's it, we're good to go. Load one of the movies, wait for it to load, play the trailer, stop playing the trailer, and then go back. Let's take a look at what that looks like. We've got 9 renders that are greater than 5 milliseconds, but if you notice here, the peaks are much smaller. There's one that stood out. We'll take a look at that in a second. What's it? 81 milliseconds. Oh, most of them are not crazy. 7.6, 7.6, 7.6. That's not crazy. So now if you notice, there's a little sparkle on the right side, and it says this component has been auto-memoized by React compiler, which is cool because now I want you to notice this. These cards that did not change because I did not click on them, they did not re-render. That's what React compiler helps us. And so overall, the little components that were re-rendering previously over and over again because we were re-rendering the entire trending now component, those don't re-render again. And that's great. There's one more tool that I want you to take a look at before we start taking a look at our code itself. And that is the performance tab with React 19. So let's go ahead and record this, and then we're going to do something similar as well. Play this and then go back. Okay. And I'm going to stop this. If you have React 19 installed, you will get this out of the box, which is this custom performance tracks that has been added in React 19 to help you understand which components are taking how much time in each of those phases. But in this section, what I want you to take a look at is how much time are your components spending in the blocking section? All right, so we've got some event mouse out happening, and see how much time it takes to render this component. These are the things that we want to optimize. For example, right here, this looks like it's taking too long. What's happening? This component, which is the fetch popular movies component, or rather the hook use popular movies, is spending a lot of time in render. And that's what's taking the longest in this graph here. Which basically means that it's not that the movie list component is taking that long. It's the hook that it's running, use popular movies, which is the one that actually calls data. That's the one that's taking so long. And that is a blocking time. It spends 85 milliseconds just trying to fetch that data. And it also shows you in this render phase which component was rendering. So you can notice here that the movie list component is rendering and all of the movie cards are rendering. And that's probably because we haven't cached any data. So every time when we land on the page, it re-renders and calls it again, which just wastes so much energy. Same thing here, which I'm guessing is the movie player component. movie detail component. And we saw while looking at our bundle graph as well that this movie detail component was super heavy. Now we can actually take a look at our components and see what they're doing. So first thing, let's take a look at movie list component, or actually movie detail component, because we know that that's the one that has been taking the longest. So what are we doing here? Which actually takes in params from the route itself, and then using that params, it actually fetches the movie detail. This is a custom hook, which actually makes a fetch call to fetch the detail of that movie. Which basically means every time we open a page, we're actually going to wait for that fetch call to come back on the client side and then load the data. So already we know this is a problem, especially if this is a lot of data that is being sent on the client. So keep that in mind. But if we scroll down here, we've got this loading error and movie component. That's fine. We've got this like a utility sort of that is sitting within the component. Every time this component renders, we've got this utility recreated. So we don't want to keep this here. Let's cut this out, put this outside, and actually, so we're going to move this to utils so that we're not creating this every time this component is created. All right, now if we come down in here, this is okay because this actually depends on the movie, which is specific to every component. And then if we come down in here, we've got a back arrow, we've got some backdrop, some images here can be optimized. We'll come to that in a second. Some more images in here, and some movie info. The biggest sort of chunk in here is this movie player. And then we've got these extra divs. Code cleanup, we'll do that later, but let's focus more on the heavy chunk of code. So then we've got this movie player here where we pass in a movie. And what this movie player does is it actually loads the video, and it is preloading metadata, which is good, which means it doesn't actually preload the entire video at once, which is good. And then it just renders this movie player. Now remember, we have actually used React compiler on this, so all of this is memoized. We don't have to actually use react.memo on this component, which means if movie doesn't change, this doesn't get re-rendered, which is good. And then we've got this detail section. So what's the biggest chunk in here that can be improved? I think the biggest chunk that is causing problem is this use movie detail, and everything else is simple. And all we gotta do is move format runtime out to our utils. Now let's take a look at movie list. In movie list, we've got this list ref, navigate, and then at the bottom here, we've got this list that we're creating for movie cards. Imagine what happens if you have movies that are like, if we have like hundreds of movies. If this movie's object is huge, we'll be spending all of that time rendering this movie card, and it's possible that the user never even looks at this movie card or doesn't even scroll past 5 images or 5 movies. So we have wasted all of that time. There's 2 things we can do here. First thing, we can actually lazy load movie card so that we only import it if we actually need it and the user actually scrolls to it. And the other thing we can do is we can actually, instead of creating this entire list based on movies, we can create a virtualized list which only renders the amount of movies that we really need to show on the screen. So React Virtualize is actually a node package created by Brian Vaughn, and setting it up is relatively straightforward. I'm not going to go into this in detail, but if creating virtualized list is important to you, take a look at this package. Highly recommended. I'm also going to make sure that instead of just rendering movie player, I'm lazy loading movie player. Now, if you remember, the other thing that we found from React Profiler and the performance track is use popular movies, which was taking too long to load. And that reason is because we're fetching from the API and setting it to true, and then setting that data, and then sending this data over to our component, which is all done on the client side. That takes too long. I want you to first take a look at your use effects before changing anything in your code. I made a whole video on 16 mistakes that are commonly found in use effects, and trust me, if you fix those mistakes, your performance is going to improve without doing anything else. Go ahead, watch it. I'll wait. Now, if you watch that video, tell me what is wrong in this code. And the answer is it's missing an abort controller, which would clean up after the use effect has stopped running, the component has unmounted. This will make sure that we abort the signal if the component has stopped running. We do not continue to fetch the movies list in the background. Hopefully you fixed your use effects by this point. So now let's go ahead and take a look at our profiler to see what we're seeing. I'm going to go ahead in performance track actually and do the same thing that I was doing, click on a movie. So let's take a look at those giant graphs. I already see that that giant graph has reduced. It used to be here. I don't see that anymore. I already feel better. But there is still some graphs in here and I want to see what's going on. Okay, so we've got 19.89 seconds. We were at 21 seconds or 23 seconds before this. Not a huge change in LCP by just the React update, which is fine because we're going to tackle that next. The next thing that I want you to focus on is when you click on LCP breakdown, it actually is pretty helpful because it shows you the time, the breakdown of each LCP phase. So in here, you'll notice that it says element render delay takes 19 milliseconds, which is actually what's taking the longest time for this to load. Now, why is this taking this long to render the element? So for that, we're going to open this documentation, optimize largest contentful paint. I'll leave a link to that in the description. And in here, we're going to check out why element render delay takes so long and how can we fix it. So what they recommend is that your goal is to ensure the LCP and element can render immediately after its resource has finished loading, no matter when that happens, right? So the reason why our element render delay is taking so long is because we wait for our style sheets to load, we wait for our JavaScript to load, and then we also wait for our data to load, which is why they recommend using server-side rendering to fix this. There are two advantages of using SSR. Your image resources will be discoverable from the HTML source. Your page content won't require additional JavaScript requests to finish before it can render. And this is where SSR can be super helpful. And this is why I want you to focus on the next part, which is where we introduce TanStack Start. Now, TanStack Start is a framework for React through which you can do full SSR, streaming, and server functions. I've covered TanStack Start in detail and showed you how to build this app from scratch with TanStack Start, and I'll link that video as well here. So check that out. But I want you to quickly know that if you scroll down to the tutorial section, in here you'll find this fetching data from external API, which is a documentation that I wrote. And in this documentation, I show you how to fetch data from an external API, which is actually the same API, TMDB, using a create server function, which actually fetches the data on the server. So all you gotta do is put your fetch call within this function called create server function, and then you get this fetch popular movies, which is what we're doing as well, within your loader. So you can just fetch from your movies like you've been doing with the router anyway. And now you have access to movies in your component. So let's implement this in our app and see how to do this. Now, I've set up my server functions so that I've got create server functions in a file here, and I've moved my fetch right in this function. I also created a new server function for fetching movie detail. So this actually replaces use popular movies and use movie detail hook. Now I've got one server function file where I've got both the server functions, that one that actually fetches trending movies and another one that fetches the movie detail. That's it. Now, if I go to my components on the main page, which is actually my home page, all I gotta do is call the loader, which is TanStack routers loader, and get movies and pass this data to my component. And I've got this available within my component. So what I've done is I used to have a use effect here, basically, that was fetching that movies. Instead of fetching an API from use effect, now I've moved it to the server by just creating a server function right here. And I'm just calling the server function from the loader, and that makes sure, because the loader runs on the server and the client, it makes sure that when my component loads, I've got the data ready from the server. Again, I go into this in detail in the TanStack Start video, so do check that out. This will make a lot more sense at the end of that video. So we want to do this for both use movie detail, which is when we open a movie card, and for use popular movies, which is the trending now component. Now I've moved all of my data to the server, and let's see if that caused a dent in LCP. Okay, give this a reload, moment of truth. Drum roll, please. By just doing that, we've reduced our LCP from 19 seconds to 12 seconds. Now, what else can we do? So we've got resource load delay pretty low here. Remember what it was before? It was 17 seconds, and now we've got it to 7 seconds. The next part to do is actually the CSS and the JS part. So we're going to tackle that next. And remember, this background image is still taking too long. So let's do this last bit of fixing where we add these fetch priorities, lazy load images, and change the priority of these CSS files as well. Now, one thing to note is that if you look at the image assets, you'll notice that the background image is the one that's taking the longest. So if this is the one that we have control over, like it's coming from a local bundle, we can easily put it on a CDN server like Netlify or Cloudflare. We can also optimize the assets that we serve so that if we are on a mobile device, we can actually show a lower resolution of image. If you're on a higher resolution device like a MacBook, we can show a better quality image and then adjust our image sizes that way. Image optimization is a full topic in itself, and let me know if you want me to make a video on that. I'm not going to get into image asset optimization in this video, but if you want a full video on that, let me know in the comments and I'll make a video on that. Put image asset and I'll make a video. So the first thing we're going to attack is our CSS file, which we know can be huge because we could be adding a lot of content in here. This is where we optimize the CSS file. In your root.tsx file, we actually specify the priority of all of the files that we are loading, including the style sheet. This is where we actually add a preload to the CSS. Stack router load CSS first. This actually increases the priority of CSS, so the content that the browser needs to render the page is available quickly. Second thing, we also want to increase the priority of images that are important for our user to view. Now remember this hero background image, which is that giant image that takes the longest to load? We know that this image is important to us. So instead of serving this from our local folder, we can actually move it to a CDN. I'm going to move this to Cloudflare, and I'm also going to increase the priority of this. Let's take a look at that in code. So here's my hero file. I've put this on Cloudinary and I've got this hero background here. I've not done anything else. I'm not optimizing the size based on the resolution. I'm just putting it on the CDN, that's all. And I'm also going to add a fetch priority equals high to let my browser know that this is an important image. Not all images are created equal. Oftentimes we want to lazy load images, but remember, there are certain images that should not be lazy loaded, they should be hastily loaded. So that's what fetch priority is for. Now, speaking of lazy loading, we want to lazy load images as well. So remember, movie card had a bunch of images. We want to add loading equals lazy to those images. Anywhere we add images that are not important, we want to add loading equals lazy to these images, loading equals lazy, fetch priority high for hero image, and loading equals lazy to these images. Sweet. The next asset that we have in our app is the video, which is where we're actually rendering data. Now, I have hard-coded movie here because I don't have any other movies. But what I want you to take a look at is the preload property here. I'm preloading only the metadata so that it only loads as little information about the video as needed. It doesn't load the entire video on render. I'm also adding a height to it so that it reduces however much shift it causes when the video actually starts loading. And there is one more thing that I want you to take a look at, which is caching and preloading. Now, the great thing about Stack router is that you get caching out of the box with Stack router. You don't have to set it up. Once you have browsed a route, it is cached for you to go and you don't have to fetch that route again. However, something smart we can do is that we know that when we hover on a card, we probably want to load it, right? So that is called preload intent. And in order to do that, we can actually configure that in a router file itself. So we can say default preload is intent, which means if I hover over a link, I want you to preload that link. You can also preload on each route and manually preload as well. So if I was to hover on a movie card, I can also by default specify that I want to preload that route. Now, we've made a lot of changes, but we haven't tested our LCP. So let's go ahead and test this. Okay, moment of truth. Also remember to keep your style sheet as well, which I ended up deleting. Now let's go ahead and measure the LCP again. All right, so now you can see, even without the data coming back, that my data is coming back, my page is loading much faster. So now the LCP has gone down to 9.32 seconds. We started at 28, we're already at 9.32. This is amazing. If you look at the LCP breakdown at this point, you'll see that the resource load delay is almost eliminated, 533 milliseconds, Basically zero. Resource load duration is 8700 milliseconds, and that's because of all of the JPEGs that we're loading. The next part is image optimization. So what we're going to do is enable cache again to see what happens when our images are optimized and images are in cache. What is the LTP we're seeing at this point? So if I give this a reload, this is still in development environment, remember. The LTP has gone down to 1.27 seconds, and that is awesome. So we did a bunch of steps to bring it down from 28 seconds to 1.27 seconds. Now, one final thing we have to do is make sure that we're testing against a production build. But let's also check what our bundle analyzer says about our bundle now. Okay, now if we look at this, our gzip version is 139 KB, map of 1.63 KB. Remember, we're still running in development environment, so some of the node modules are not optimized. But if you look at this source file, our source is only 4.65 KB, which is awesome. The biggest chunk is still React DOM client, but that's fine, which is something we need anyway. You'll notice that that hero background is also removed because we put it on the CDN server now. So our package size looks much more manageable. All in all, we're at 395 KB, which is pretty good. You'll also see that we also have a gzip version, which is 139 KB, and the Brotli is 121 KB. So good optimizations. So this is what we started with. We started with 28 seconds. We had a huge index file, gzip of 640 KB. We started by looking at the bundle to see what our app looked like. We added a bunch of optimizations like lazy components, minifying CSS, JavaScript, code splitting, and removing unused NPM packages, and we came down to 21 seconds. We then took a look at our package and noticed that it was much easier to understand where the heaviest components was by looking at the bundle. Our bundle size started decreasing when we removed all these extra files. We added server functions, which is what helped in reducing that element render delay, which helped us bring the LCP down to 13 seconds. Then finally, we added lazy loading of images, because of which we came down to 1.27 seconds with a gzip of 157 KB. So as you saw, we took an extremely slow app and step by step improved the app while keeping performance and metrics in mind. Now I want to know from you, what did you learn from the video? Was there something that stood out to you? Put it in the comments. I also want to know if there's an optimization that you do that I didn't talk about. I'd love to know about it. Put it in the comments. And now, watch this TanStack start video.